All right, so we are working in section 7.3. We're talking about operational properties. We are doing a new example, and this is the example we're doing. We're going to find the inverse Laplace transform of this particular interesting function of S. And we learned last time about two what are called translation theorems, and they were helpful in helping us find new kinds of Laplace, inverse Laplace transforms. So let me give you a moment to copy down this. This is a biggie, Matthew. This is a biggie. This is a long example. So make sure you have notebook paper, everybody. Remember now, you're near the end. Sure, you're welcome. You're near the end of differential equations, right? I mean, you've learned a lot of differential equations, and so of course the problems get a little bit harder, of course, or a little bit more involved. But you're able to do more complicated problems too. And actually, for section 7.3, I'm going to split the homework up into an assignment that's due on Sunday and an assignment that's due on Tuesday. Okay, so because I know these problems take time. Okay, let me give you a moment here. Okay, so again, we have to think of these problems as like puzzles to solve. And we have here, and let me just get the document right in front of me. We have here really well, this fraction that we have in this example. Well, let me phrase it like this. So where does your attention focus on this? Where does your attention focus? Well, okay, the half, but is there someplace else? Factoring, okay, Matthew's talking about factoring. So if we're thinking of factoring, the s squared plus 7s in the denominator is very important, right? Very important for factoring. So we're gonna, of course, have to do some completing of the square here. Okay, so let's go to the solution here and begin. So what I'm going to do is I'm going to write the denominator as the sum of two squared terms. Now s squared plus 7s, okay, if I take 7 and divide it by 2 and square that, I'm going to get 49 fourths. 49 fourths. So that's the term that I want to have here. Okay, so that this this expression here is equal to the quantity s plus 7 halves squared. But then the negative 49 fourths plus 16 just becomes 15 fourths. So I can write the denominator as the sum of two squared terms. And you know based on your Laplace transforms that some of those Laplace transforms have a denominator with the sum of two squared terms. Okay, so that gets us up to here. And of course, what I want to do is I can write this expression inside here as the difference of two fractions, and that's what I do. I write it as the difference of two fractions, and I factor out, of course, the negative 3 halves and the negative 21 halves. So just kind of look at it carefully. Let me know if you have any questions. Okay. Now let me ask you, what would we like up here in that numerator? What would we like to have here?
Square root of 15 over 2.
Well,
oh, sorry, I was looking at the wrong half.
yeah. What about here, Justin? What about in everybody? What about right here?
S plus 7 over 2.
That's good. That's good. And actually, oh, hold on. I guess I got to go down a little bit. So I'm going to put an S plus 7 over 2 there. But then, of course, I have to subtract 7 halves. Okay. So that the numerator is still S. And then on the right side here, okay, well, I have a constant of 1 on top, but because I have a root 15 over 2 here, I want a root 15 over 2 in the numerator. But to get a root 15 over 2 in the numerator, well, what do I have to do? I have to multiply by 2 over root 15. Okay. So it's just manipulation, All right. Are there any questions at all? Okay, I'll wait here. What do you think the natural thing to do here would be? S plus 7 halves minus 7 halves. The reason I'm adding the 7 halves and subtracting 7 halves, Zachary, is here I have an S. But I want there to be an S plus 7 halves in the numerator because I have an S plus 7 halves here. Okay, so I get an S plus 7 halves then in the numerator, but then I have to subtract 7 halves. But it's also I can get an S plus 7 halves right here.
I have a question.
Yes, Antonio.
So with that -7/2 that we have now, would we split that again into like what we did on the right and then factor out?
Exactly. Very
Okay.
good. We are going to split that. We're gonna bring. We are gonna do that.
Gotcha.
We are
We'll have
indeed.
3 terms instead of 2.
That is correct.
Nice.
Man, Antonio is one of our Laplace transform experts here, right? All right. Excellent. Excellent. All right. May I go to the next page? Maybe give me a few thumbs up if we're ready. Okay. All right, Andrea. Very good. Okay. So we are going to split up this first term into s plus 7/2 and then -7/2. But don't forget, we're multiplying by that -3/2 in front. So that's going to get us here. Oh, and by the way, now here for this inverse Laplace transform, we're ready to do that inverse Laplace transform. We're ready to do it. And we're going to be using a translation theorem, right? Translation theorem, the first translation theorem to get the inverse Laplace transform. Okay, and so this is where we are now. I split the first inverse Laplace transform into these 2 terms. And I have then, of course, now I was able to take the inverse Laplace transform of the third term.
Wait, so for this right side term here, where'd you
This
get
one
like
here?
yeah, the top right.
Oh, this here. Okay.
Yeah. Or I guess, yeah, where did you get both of those terms?
So what I did, let me just, hold on, class. This here, s plus 7/2 minus 7/2, I write that as 2 fractions. S plus 7/2 and then a minus 7/2. I split that up into 2 fractions. S plus 7/2.
And then the minus 7/2 is the third term there?
That's the second term, right? The minus 7/2 here. Right.
Oh.
Right.
Okay, I see. And then the third one you just did the transformation because you figured.
That's correct.
Okay.
That's right. Okay, and now at this stage, the first inverse Laplace transform is in the right condition so that we can get its inverse Laplace transform using the first translation theorem. Now the second inverse Laplace transform, what do we want up here in the numerator? Do we want a -7/2 up there in the numerator? What do we want up there so that we can take, what do we want in the numerator so that we can take the inverse Laplace transform? What number?
It's got to be root 15
on 2.
That's right, root 15 over 2, because we have root, our k squared is root 15 over 2 squared. So we want root 15 over 2. So okay, I'll put it up. here, but then I have to, but then I gotta multiply by the reciprocal, 2 over root 15, and then the negative 7/2 I pulled out in front. Okay, so that gets us here. Okay, and so, all right, well, now the product of negative 3/2, negative 7/2, and 2 over root 15 is just 21 over 2 root 15. Okay. And the inverse Laplace transform of root 15 over 2 over the sum of those numbers squared, the root 15 over 2 over the denominator there. That's just using the first translation theorem, e to the negative 7/2 t times the sine of root 15 over 2t. And you notice I try not to do too many steps at once with these inverse Laplace transforms, the section 7.3. Try not to do too many steps at once because you know, it's important that you see how it works, and then when you do the problems, I want you to show me how it works, right? That you understand what to do. So showing these steps is important. Let me see here. So let's see. Question. Mark had a question about the negative 42 at the bottom. Let me see. Hold on here. Mark, good catch. This should be negative. Yep. This here is negative. A negative 42 over 2 root 15. Yes, that's correct. Thank you.
Professor?
Yes, Antonio.
I was just wondering if you could go over real quick why we get the e and the cosine or the sine term. I know we did it last week, but I forgot.
It has to do, well, we did it actually on Tuesday. It has to do with the first translation theorem. So, like, for instance, if you were to do the Laplace transform, or the inverse Laplace transform of, let me see here.
Oh.
Yeah, so all you're doing is the first translation theorem.
Right. Because it's f of the s minus a.
Right, f of s. Right. This here is big F of s minus negative 7/2.
So you're kind of just solving these as if they're f of s and then adding the e to the at, whatever a is.
That's correct. Well, and then negative 7/2 is the a.
Right. Yeah.
Correct.
Okay.
That's right.
That makes sense.
That's right.
Thank you.
Sure, no problem.
Professor, please could you go to the very first page of the solution? I think
Let me see. Hold on here. One moment. I'm actually one moment here. One moment, Michael. One moment. Okay, all right, we're all, yeah, let's go to the last page. Are we good, everybody here?
I think he wanted to go to the first page, or maybe I'm wrong. I don't know.
Yeah, the first page of this solution.
Oh, okay, Michael, all right. Page, I think this is the easy way. But let me make sure everybody has this copied down. What I'm showing you is what I would show on the board if we were in the classroom. What I would show you here is what's on the board, and I'm trying to show the steps carefully. I could just have, I mean, I always like to sort of when I do a solution, go over the solution with you, rather than just kind of give you a document with the solution and say, hey, everybody, look, just look on your own, But of course, we have to make adjustments because you're not right in front of me. So, Michael, you want to go to the first page?
Yes, thanks.
Okay. Yeah, what's your question?
Okay, okay, why couldn't we factor out 3/2 in that's from the beginning? We factor out
Because you
3/2
haven't.
and then we'll have s plus 7, and then we can write 7 as 7/2 plus 7/2 rather than doing it.
Well, this is how I'm doing it. I'm not saying you could maybe do it another way, but this is how I'm doing it. I'm not saying my way is, the only way, but I mean, any way you slice it, you're going to end up doing what I'm doing one way or another. Maybe what we can do is after class, I can take a look at kind of what you want to do, and I can comment on that. Does that sound good, Michael?
Yeah, because, well, it gives the same solution. It's just that
Yeah, I
it
mean,
would have
there's
been.
different ways. Paige, do you have a question? Paige, are you understanding things all right? Do you have any questions?
Yeah, I'm okay. I was just kind of confused because of like the factoring in the first example, but with what Michael said, that makes more sense to me. So I think I might do it that way.
Okay, okay, very good, very good, excellent, excellent. I see. You're wondering, is there like another approach? And okay, yeah, class, they're depending. Sure, excellent, excellent. So now the last page, what I do in the last page here is I try to both. There are two terms. There are two terms that have e to the negative 7/2 t times the sine of root 15 over t. There are two terms. Now you could have, like in WebAssign, you could type the answer that we had on the previous page, but you could also combine the two terms. And if you did, you would get a term like, you would get this as your final answer. Okay, so I just wanted to share that with you. What I do is I combine these two fractions here and get it in simplified radical form. It's really just that.
Yeah, I think what people were kind of talking about with the whole factoring out the negative 3/2, with that second to last line, I mean, instead of simplifying that second coefficient, you could have just pulled a 3/2 out, or a negative 3/2, and ended up with plus 7 over root 15.
Oh, well, okay,
I
okay.
don't think it doesn't matter at the end of the day, but
When I did this problem, I did it kind of cold, I do it cold turkey, so to speak, like a student would do it. And this just seemed good, comfortable with me. But sure, there are different things. Sure, different ways. Somebody, I remember one time, a long time ago, I was on a date. This isn't really a math thing, but I was on a date, and the person I was on the date with said that mathematicians aren't very creative, she said. And I thought, wow, I think we're pretty creative, right? Aren't we? Aren't we creative here?
Yeah, you have to be.
Yeah.
Yeah. So, all right. That might have been a Match.com date. I don't remember, to be honest. Okay. So, all right. Are there any questions? Before we move to, I'd like to try to do a few more examples here. The more examples I give you, the better you'll be with the homework. And as you know, for the final exam, this is a very, very important, Laplace transforms. And incidentally, the final exam, it'll be constructed just like the exam 4, and the same kind of thing. But it won't be restricted to a 2-hour window, but you'll have quite a bit of time to complete the final exam. As a matter of fact, final exam part 1 would not be due until, during final exam week. Part 1 would not be due until Thursday, May 13th. And at I guess 4:55 p.m. or whatever. Thursday, May 13th. Would be the part 1 of the exam when it would be due, and then Saturday, May the 15th would be when part 2. Or wait, no, I have that switched. It would be Wednesday. Well, what I'm trying to say is you're going to have ample time to work on my final exam, and you'll be able to take your other final exams too. I'll get the due dates and stuff, and we'll talk about it next week. But what I'm trying to say is, the final exam, you'll have ample time to do it. And I think, Antonio, it will be basically the length of like a regular exam, roughly. I want to, like the previous ones, 3.5 hours for each part. Really, I don't think you need even 3 hours, but it seems people like to have the extra time, so that's cool. That's fine.
Can you go back to the previous page just for a second?
Yeah. Back to the previous page. Zachary, all right, Matthew. Zachary, yeah. So it'll have, it'll be like the previous exam, Zachary, where you have some flexibility when you can take it. Yes.
Okay, I'm good. Thank you.
All right. Let's see here. All right. So let me bring up. Hold on, Christopher. Hold that thought. Let me bring up a new example now. New example. Let me see here. One moment. No, that isn't it. One moment, class. One moment. Thank you, Michael. Thank you. Let me see here, class. I gotta find the document. Let me stop the recording on this.